Determine higher order derivatives requiring the chain rule. So in this video we're going to talk about how to find the higher order derivatives that do require us to use the chain rule. So let's take a look at our first example. So here we have h of x is equal to the quantity 2x squared plus 7 raised to the 5th power. And as we can see, this is an expression, or this is a function that requires the chain rule, because we have an inner function and we have an outer function. And the example is asking us to find the second derivative of h of x. So we know to find the second derivative, we just have to take the derivative 2 times. So let's go ahead and let's take the derivative 1 time. So we're going to have h prime of x is equal to, and let's remember the chain rule says we take the derivative of the outer function first. So that'll be 5 times the quantity raised to the 4th power. Then we put the inside function back inside, and then we multiply the outside by the derivative of the inner function, which in this case happens to be 4x. And then we can simplify this by doing 5 times 4x to get a first derivative of 20x times 2x squared plus 7 raised to the 4th. Now, since we're taking the second derivative here, we do want to simplify our first derivative down as much as possible. Because if we left it the way we did in the very first step, we can see that we have a product, which means we are going to have to, dang it. Now, when we are, Now, when we do take the first derivative, we do want to simplify it down as much as possible like we did here, because it'll make taking the second derivative much easier. So, let's go ahead and take the second. You gotta be kidding me. So let's go ahead and take the second derivative. So we can see that h double prime of x is going to be, well, if we look at our first derivative, we can see that we have a product rule. So that means we're going to have a first function, and we're going to have a second function. So when we take the derivative of the first function, that's going to be nice and simple. The derivative of 20x is just going to be 20. Then times the second function, 2x squared plus 7 raised to the 4th power. Plus our first function, which is 20x, and then we need to take the derivative of our second function. However, our second function requires the chain rule because we have an inside function and we have an outside function. So, chain rule says we take the derivative of the outside function first, so that'll be 4 times whatever the inside is, raised to the 3rd power. We'll put that inside back on the inside and multiply the outside by the derivative of that, which is 4x. Alright, so we did take the derivative, now we just have to simplify. So the first term is just going to stay how it is, 20 times the quantity, 2x squared plus 7 raised to the 4th power, plus, well then for the second term, we can multiply the 20x by the 4 with the 4x, because those are all on the outside. So let's see, 20 times 4 is 80, 80 times 4 is 320. So we're going to have 320 x squared times the quantity 2x squared plus 7 cubed. Alright, so now this is simplified, but it's not simplified enough for Newton, because remember when we do use the product rule of Newton, we need to simplify completely. So we're going to first look at the outer terms to see what they have in common, and we can see that 20 and 320 both have a 20 in common. So we can put that 20 in the front. And then we're going to look at our next set of terms, the 2x plus 7 to the 4th and 2x plus 7 cubed. And we can see there we have a 2x squared plus 7 to the 3rd power in common. So we can factor that out. And that means we're going to be left with 2x squared plus 7 plus 16x squared. And then we just have to simplify the inside to get our fully simplified version. So this will be 20 times 2x squared plus 7 cubed. And we can combine the like terms. 2x squared plus 16x squared is going to be 18x squared plus 7. And there we go. We have the second derivative of h of x. So let's take a look at another one. It's very similar. We're given a function, the quantity 4 minus 6x squared, all raised to the 6th power, and we're being asked to find the second derivative of f. So that is going to require the first derivative first. So f prime of x is going to equal, well, let's see, we do have an inner function, and we do have an outer function. So chain rule says take the derivative of the outer function first, put the inner function back inside, and multiply by the derivative of the inside. So we're going to get 6 times the quantity 4 minus x squared raised to the 5th power times negative 12. Well, then we can multiply this 6 times the negative 12x, and that's going to give us a simplified derivative of negative 72x times 4 minus 6x squared to the 5th. And now it's second derivative time, so f double prime of x. And we can see here that we're going to have a product rule, so we'll have a first function, and we will have a second function. Product rule says we take the derivative of the first function, which will be negative 72. We'll multiply it by the second, 4 minus 6x squared to the 5th. And then we will add the original first function, which is negative 72x. And then we need to take the derivative of our second function, which sadly does require the chain rule, because we do have an inner function, and we do have an outer function. So chain rule says we take the derivative of the outer function first. We put that inner function back inside, and we multiply by the derivative of the inner function, which is negative 12x. From here, then, we can simplify. Not much we can do with that first term, so we're just going to have negative 72 times the quantity 4 minus 6x squared to the 5th. However, with the second term, we can do the negative 72 and the 5 and the negative 12. So let's see. Negative 72 times 5 times negative 12 is going to give us a very large number. It's going to give us 4,320x squared. And that's going to be times the quantity 4 minus 6x squared to the 4th. All right, so now we need to factor this even more. So we can look at both of the first functions in each of these terms, and we can see, well, what does 72 and 4,320 both have in common? And they both have a 72 in common. And then we can look at the 4 minus 6x squared parts, and we can see that both of those terms are going to have a 4 minus 6x squared to the 4th power in common. So we can factor that out. 4 minus 6x squared to the 4th. And let's see, that's going to leave us with negative the quantity negative the quantity of 4 minus 6x squared plus 60x squared. All right, now we just need to simplify the inside, and we are going to need to take this negative and distribute it through. So that's going to leave us with 72 times 4 minus 6x squared to the 4th times negative 4 plus 6x squared plus 60x squared. And then we can simplify this one more time to get our final answer of 72 times the quantity 4 minus 6x squared times 66x squared minus 4 as the second derivative of f. And now our final example, we're going to find the second derivative of sine of negative 2x plus 2. All right, so we are trying to find the second derivative, which means we're going to have to take the derivative twice. So let's go ahead and let's take the derivative once. So d over dx of sine of negative 2x plus 2. Well, let's see, we do have an inner function and we do have an outer function here. And in our final example, we want to find the second derivative of sine of negative 2x plus 2. So we are looking for the second derivative. So we want to do d squared over dx squared of sine of negative 2x plus 2. Well, we know the second derivative is the derivative of the first derivative. So we could break this apart to be d dx of d dx of our function sine of negative 2x plus 2. Well, in order to take the derivative of sine of negative 2x plus 2, we need to recognize that we need the chain rule because we have an inner function and an outer function. So that means we're going to take the derivative, the first derivative, and the derivative of the outside is going to be cosine. We are going to leave the inside alone, negative 2x plus 2, and then we're going to multiply by the derivative of the inside, which is negative 2. All right, then we can bring that negative 2 to the front to rewrite the first derivative as negative 2 times cosine of negative 2x plus 2. And at this point, we have only taken one derivative by noting that we still have one to take the derivative of notation out of the beginning. Remember, that's what the d dx stands for. It means we have to still take the derivative. Now, based on one of our derivative properties from earlier videos, we know that we can take this coefficient and we can pull it out. So that's going to be our next step. That's going to leave us with negative 2 times the derivative of cosine of negative 2x plus 2. And when we want to take the derivative of that, we need to notice that it's another chain rule because we have an inside and an outside function. So that 2 is just going to stay on the outside. Nothing's going to change there. But when we take the derivative of our of our cosine function, the derivative of cosine is negative sine. We're going to leave the inside function alone, and then we're going to multiply by the derivative of the inside, which is negative 2. And now we just need to simplify because all the derivatives are taken. All the d dx notation has been applied. And let's see, we can multiply the negative 2 with the negative in front of the sign with the other negative 2. And that's going to leave us with negative 4. And then we can bring down the sign of negative 2x plus 2. And there we have it, the second derivative of sine of negative 2x plus 2. All right, and that's it, folks. That is determining the higher order derivatives requiring the chain rule.